the basics of the Cello transaction structure and like tools that we can use to send transactions. I created a GitHub repo that kind of outlines all the code that I'm going to be going through today. I'm just going to do a screen share where I have a JavaScript file and we're going to go through a JavaScript file and kind of like outline the transaction structure, some of the tools we can use to sign transactions, and then also send those transactions. And then also connect to a basic web page for using like the Cello extension wallet. It's a Chrome browser extension. It's similar to MetaMask. And then I'll also show how to like send Cello dollar transactions using Galora with the dApp SDK. So this workshop is going to be, I'm just going to share my screen and go over code. So it's going to be pretty technical, but it's like relatively basic. There's no real advanced coding going on. I'm just going to use the code to show kind of like the structure and how it looks on the JavaScript side of things. So for some of you, I don't imagine all of you guys are like developers here that are actually going to be coding the project, but I hope this can be like an overview that helps you get a better understanding of what's working at the lower level and then what's possible. And I also want this to be interactive. So even like less technical folks can jump in and ask questions about exactly what's going on or why things are the way they are. Because the current material I have isn't going to fill the entire hour. So I want you guys to jump in and ask questions as you have them. Because I think, yeah, if you have a question, someone else likely has a question as well. So I just wanted to start with that. And I'll start. I'm going to start just sharing my VS Code. Okay, yeah, you guys are seeing this lesson. So this is the repo that I shared in GitHub. Basically, this README just has some instructions about how to get started with the repo. So basic requirements are just familiarity with JavaScript and basic web development. But even if you don't have that, as I go through this, you guys will be able to get some understanding because I'll be explaining everything. But essentially, when you download this, you just install the dependencies. And then a prerequisite to getting started is actually creating an account that we're going to be using for the exercises. And there's a script here. So I have all the dependencies installed, but I can just run like node create account. And this is going to run a script and it's going to just create a new account for me with like a private key and an address. So the address is like the identifier that tells where you're going to send any funds or any transfers. And the private key is the sensitive information that actually signs the transactions and makes them verified by the network. So this private key is something that only the account holder should have, because otherwise anybody can send funds. So anybody that's holding the private key can send transactions on behalf of this account. So I store this information in an environment file, which is just a way that we're going to import this into our lesson. So like I have a private key here. And this is a good practice just for keeping your private key in one place that's not shared anywhere. And then in the actual lesson, I import the private key into this file for signing things. So we'll get to that in a second. But that's just how you get started with this. So after you create an account, and then paste that information into the environment file, we can jump into lesson.js. And in this, we're going to go over, I have comments throughout this entire file, so it makes it a little easier to parse as you guys are going through it, even for less technical folks. So yeah, in this walkthrough, we're going to go over the structure of a Cello transaction. And just real quick, is this big enough for you guys, or should I make it bigger? It's good.
Okay. A bit bigger would be better.
Yeah.
Let's try that.
Okay, cool.
All right, so yeah, we're going to go over the structure of a Cello transaction, how and why it's different than Ethereum transactions. And then we're going to go over some basic tools of like sending Cello and CUSD with the ContractKit SDK, Web3.js, which is a popular JavaScript library for Ethereum, as well as Ethers.js, because I know it's gaining in popularity with the Web3.js. So we'll go over both. So the initial, like section 1, we just go over setup. So we just need to import the packages that we're going to use for doing these actions. So we have a Web3 package, we have the ContractKit package, we have a Cello Ethers wrapper, which is going to make Ethers.js compatible with Cello because the transaction objects are slightly different. This .end library just pulls in the variables in the environment file that we define, like the private key. And then we have the Ethers library as well. So once we have that, we can actually set up Web3 to connect to the Cello network. I'm using Figment network, which I have a link to in the GitHub repository in the README. There's a link to the specific Cello page, but this essentially lets us make a remote connection to the Cello network. And this Figment API will just send any queries we have to the chain through their node, or send any signed transactions through their node to broadcast them through the network. So it makes it really easy. We don't have to run a node to connect to the network. You can run a node locally and send all your requests through that, but this is just an easy way to get started. And I mean, they also provide like production grade services, so you can build production applications with this as well. So in the environment file, I actually have my Figment API key here as well. And that's just added to the URL. So you guys can just go to the Figment network website and create an account and put in your API key there. Alternatively, we have like Forno, which is run by C Labs, but it's a similar service, but it's not as feature rich as Figment's service. So I've been recommending Figment lately. Once we make a connection to the network, we can.
Hey, Josh.
Yep.
The question in the chat, is the Web3 package same as the one from Ethereum?
Yes. Yep. So a lot of ContractKit under the hood is using Web3, but there's some additional functionality to handle the additional transaction fields. So there are some differences with ContractKit, as well as like ContractKit includes a bunch of contract wrappers to make it easy to connect to the protocol contracts. So yeah, Web3 is the same. And we're working on decoupling ContractKit from Web3, so you don't necessarily have to use it, but you can still get this additional functionality from ContractKit. But yeah, you can see once we make this connection with Web3, we can create an instance of ContractKit from Web3. And we just have that for the remainder of the file. And then for actually using our account and our private keys, we just use the Web3 library exactly and say, we're going to turn our private key into account, and then we just make this account variable available for the rest of the script. So that's it for setup. Now we have an account, we have a connection to the Cello network, and we have our libraries pulled in, and now we can start signing and sending transactions. So in this first example, I just want to go over signing an example Ethereum transaction, because an Ethereum transaction is very similar to Cello. Cello just has a few additional fields. So we can take this, I'm defining an Ethereum transaction here, and there's just, what is it? Like 8 different fields that I specify. We want to specify who we're sending a transaction to. We want to specify gas amount. So that's, gas is, since Ethereum is a Turing complete virtual machine, there needs to be a way to make sure we don't get into infinite loops or like code that will break the virtual machine. And gas is a metering tool that helps the EVM basically limit the amount of execution that can happen on the virtual machine. So there's a specific amount of gas that we want to send with any transaction, and this can be a higher number than what you actually need, because any surplus gas will be returned to the sending account after the transaction is executed. So you just can send more than you need. There are libraries that will estimate this when you send the transaction, but I'm just hard coding it here for visibility. We specify a from account. So this is just going to be our account address. It's the address that we're signing the transaction with. We have the nonce, which is every transaction coming from an account needs a unique nonce. It's just a number that's only used one time. So if you send 2 transactions with the same nonce, only one of them will be valid. So this prevents people from replaying transactions that have already been sent on the network. We have a chain ID. This is actually the Cello mainnet chain ID, so this wouldn't be an Ethereum transaction. To make this an Ethereum mainnet transaction, we actually make this 1, because Ethereum mainnet chain ID is 1. And then for various test nets, you just change this number to execute on different test nets. So I think Alpha Juarez is like 4, 4, 7. There's a bunch. There's 4s and then 6, 7s and 8s in there. It's like 5 digits long. So yeah, change this number to execute transactions on different Ethereum networks. There's a data field. This is a hex encoded string, and this encoded data is specifies information for smart contract execution. So when you send data to a smart contract to execute some arbitrary code, there will be a bunch of information encoded in this data field. We'll see more on that later. Value is the actual amount of ether that you want to send, but this is denoted in way. So it would be 10 would be like 10 to the negative 17 ether. So like 1 unit of way is 10 to the negative 18 ether. So to actually make this 1 ether, I would need to add a 1 with 18 zeros here. And then there's a gas price, which is how much of the native currency, so ether in this case, that you want to pay for each step of execution of gas. So this determines the transaction price. The gas used and then the gas price determines how much your transaction will actually cost. So now that we have that Ethereum transaction defined, we can actually see what a signed Ethereum transaction looks like. So I'm just gonna have this function defined here that's just signing the Ethereum transaction with the account private key. And then I'm logging it to the console. I'm just gonna run that with by running the JavaScript file. So we can see here we have this signed ETH transaction, which returns like a hash of the message. This V, R, and S are variables that define the signature, which will be included in the broadcasted transaction. And then here's the raw transaction. So this would actually be what you'd send to the network that would be interpreted by the EVM and included in the next block, potentially, or a future block. So yeah, that's the basics of an Ethereum transaction. Is that familiar to you guys? Any questions there?
Hey Josh, a quick question on the gas price. So it seems like, at least with Ethereum, the price of running any sort of function is like super high right now. And right now the price of Cello is still on the lower side, but just trying to understand how the transaction price will change as the value of Cello grows.
Yeah, so you can see here I have this note that's like 0.5 Gwei, which is actually an amount of, in this case, ether. So it'd be 0.5 Gwei worth of ether. Ether's trading at like around 2,000, several $100s right now. So, and so that's going to be a more expensive gas price than like in Cello. If the gas price is 0.5 Gwei, Cello's trading around like $4 something. So yeah, there's just like orders of magnitude difference in the price. So like this price is denominated in like the native asset of the network. So on Ethereum, that's Ether. On Cello, that's Cello. And the difference in price of the active like trading amount is important in determining like how much that is.
If the price of Cello ever grows to a point where it's like super high, are there any like
I need to see.
Sorry. Can you repeat the question?
Yeah, no, so I'm just saying that if as the price of Cello grows, right, is there any way to sort of, I mean, the gas price would probably be the same, but the price of the transaction will increase. And if there's like a high volume of transactions, that entire price will obviously increase, right? So just wondering if there are like any sort of ways to just keep that price low or something, or just trying to understand that a bit better.
That's a good question. So currently, I think transactions on Ethereum have been between like 100 and 200 Gwei. And that's because the blocks are full. Like there's a lot of demand for space in those blocks. The blocks are less full on Cello, so the price is less, so it's 0.5 Gwei. As the blocks fill up, it's easy to imagine how this number will go up. And also if the price of Cello increases, transactions will become more expensive. So the engineering team is working on like increasing throughput, which will mean there's essentially more space to include transactions in, which means because their blocks will be larger, but they'll also be more frequent than on Ethereum. That only gets us like a little bit of scalability. It's easy to imagine how in the future when Cello blocks are full, there will need to be additional ways to scale the network. And I think some of the most promising things are just the layer 2 scaling solutions that are being researched on Ethereum. Since Cello is an EVM compatible chain, all of the layer 2 scaling solutions that are being developed for Ethereum can be redeployed onto Cello. So that will allow block space to remain, just increase availability of block space and keep this number low.
Yeah.
Okay.
A good example of this, guys, is Binance. Like 3 months ago, it was basically the same price as Cello, and now it's increased like 100 times in literally 3 months. The interesting thing about Binance, though, is the $250 or $500 worth of Binance coin I bought 3 months ago is now worth like $5,000. So there's some hedging I think you'd have to do for gas. At least that's what I do. So you can kind of use a couple currencies and trade against it to make sure that you're not getting killed on that.
Got it.
There's obviously a lot of.
I have a quick question. Do you have an example of this where we can pay the gas fees using the stable coins?
Yep, I'm going to get to that.
All right, perfect.
Yep. Cool. So yeah, let's keep going down into like signing a example Cello transaction. So here, here's a Cello transaction object, and I copied almost everything the same as the Ethereum transaction object, but there's these 3 additional fields. So we have a gateway fee recipient, and a fee currency. And these 3 additional fields were added to Cello to help basically to help incentivize the creation of full nodes, which will serve the ultralight clients that are running on mobile devices. So if we have billions of mobile phones that are running ultralight clients, we need a bunch of full nodes to help support all of that, all of those mobile nodes. So that's where like gateway fee and gateway fee recipient come in the transaction object. So gateway fee recipients, like these would be full nodes that are supporting mobile, the light nodes. And we also have gateway fees. So like how much are mobile nodes actually paying the full nodes for the services that they're providing. Currently, this is not turned on. So like the gateway fee recipient can be 0 or none. And the gateway fee can also be 0. Like you don't actually have to include a gateway fee to have these things relayed, especially if you're connecting to a service like Figment, who are relaying transactions for you. But this is something that can be turned on in the future to promote this like decentralization of the network and build a more robust network with more full nodes. We also have this fee currency field, which allows you to pay transaction fees in alternative currencies. So this is an address of a smart contract, and it's actually the Cello dollar smart contract on Alpha Horus. So if you put this address in your fee currency field, then it will actually debit the account CUSD balance instead of the Cello balance for paying transaction fees. So this is like one of the features added to make Cello, like improve the user experience of Cello in the sense like you don't need multiple currencies in your wallet to pay transaction fees. You can just have you can just have Cello dollars in your account, or like in the future, it's just Cello euro in your account, and you can pay transaction fees in those alternative currencies.
How is the fee calculated in relation to the gold token? Because if the gold token increases, I guess that the fee for transactions in stable currency will increase too, right?
Yeah. The fee, like if blocks are filling up, the fee will increase accordingly, whether it's you're paying transaction fees in Cello or Cello dollars.
Yeah, but if the value of the Celo increases, but not the network itself is not lowered, does the value for fees in stablecoin also increases?
Yes. Yep. Yeah. So there's some magic that will happen under the hood with ContractKit that calculate. It will basically figure out what the current like market price is for gas, and then it will calculate it into Cello dollars for you. So yeah, if Cello is increasing in value and this is going up, then it will be a corresponding increase in the Cello dollars. Yeah.
Okay, thank you.
Yeah.
And is it in the back end, is that being converted back into Cello, or the miners are getting paid in that CUSD itself? Like how is it working?
I believe they're getting paid in Cello dollars. I'm not totally sure. We can look at a transaction in the Explorer and trace it a little later on when we're sending it. Try and figure it out. All right. So yeah, let's see how to actually use ContractKit to sign this Cello transaction. So I'm actually going to add the private key to ContractKit using this line. Yeah, it's just kit.connection.add account. And then I'm going to set the default account of ContractKit to the address associated with the private key. So then when I run the sign Cello transaction function, we can see, so this output's a little bit different because just the way ContractKit is printing it. So ContractKit will actually print all of these inputs that we put into it. And then this V, R, and S, which are the like cryptographic signature variables. Then we have the transaction hash. And then here's the raw transaction that will be broadcast to the network, just a long hex encoded string. So yeah.
I have a question.
Yep.
So like on testnet as well, once this is broadcasted, is there a way to sort of monitor that particular transaction hash for the confirmation time? So sort of like to know when it's been delivered completely.
Yep. Yeah, we'll actually get to that in the next bit, I think.
Okay, no worries.
Yeah. So I'm going to comment that out. Yeah, and just to like review what I did here, because this is just signing the transaction, it's not actually sending it to the network. I'm getting the wallet from ContractKit. So when I add this private key to ContractKit, it creates a wallet. So then I get the wallet and then I just use the wallet to sign the transaction. Whereas in this next example, I'm actually going to show how to send the transaction, which will do the signing and then also broadcasting it to the network in the same function. So yeah, here in section 4, we're going to send the Cello transaction. And what I do here is similar to above, but instead of hard coding the nonce, what I'm going to do is get it programmatically. So I'm just getting the number of transactions from the account using ContractKit. We're using Web3 connected to ContractKit because like this number, every time I send a transaction, the number will increment. So unless I'm tracking that somewhere in my code, it's easier just to get the transaction count from the network and say, how many transactions has this account sent? I'll do one more, and then it will be the appropriate nonce. in this transaction, I want to send 0.1 Cello. So I'm just going to convert 0.01 into Cello. But since we're using the Ethereum Web3.js library, we're just using some syntax that's legacy from Ethereum. So converting 0.1 Ether, which is actually Cello. Just a naming convention here that hasn't been changed. And if we encode the Cello transaction, I'm going to send it to this address. I'm going to specify the alpha horse chain ID, which is 44787. There's going to be no data because this is just a basic Cello transfer, and I'm going to send the amount. And then for like gas price, gateway fee recipient, and fee currency, I can actually omit those from the Cello transaction, and ContractKit will just fill them with the default parameters, which is nothing right now. So fee currency will be Cello. There will be no gateway fee recipient, no gateway fee, and then gas price will just be the current gas price will be retrieved from the network because we actually have a contract on chain that is saving the current gas price on the current micro price. So you can just ContractKit will get that automatically for you. So let me make sure I have the old line commented out. Okay, so once I have the transaction object created, I just call kit send transaction and put the transaction in there. And then to your question earlier, like this is an async function, so we wait for the transaction to be signed and then return to TX. And then we wait for the receipt, which means the transaction will be broadcast to the network, and then we'll get confirmation that the transaction has been confirmed on the network, and that will give us a receipt. From that receipt, we'll actually, I'm just going to console log the transaction receipt linked to the Alpha Horse Block Explorer. So this should just return a link to the Block Explorer that we can click on and check it out. Just want to open this. You guys can't see it right now, so I need to share my entire screen. Yep, here's the transaction. Just happened 18 seconds ago. It's for 0.1 Cello. It got the gas price of 0.5 Gwei. We can just see it was like a basic transfer to this account that we specified from 988, which is what we said here. So that's a basic Cello transfer, just encoding everything yourself in the transaction object.
Can I ask a follow-up question if you're not done? If you're done, sorry.
Yep.
So that's thanks actually for clarifying on the receipt. I didn't know that's essentially how you could you could get then the confirmation. But to ask like about the scalability of this, when sort of like when Cello becomes broadly used, and then block confirmation times also increase just because of like the number of transactions being confirmed, like you were explaining a bit earlier. Would the asynchronous operation then be advised, or is there sort of like a webhook approach where you could just monitor like a particular node if you are monitoring like transactions happening on a particular node? I don't know if you get the question I'm asking.
Yeah, so block times won't actually increase as the network gets more, as the network gets popular. Like it will always be faster block times. Yeah, so it's always going to be fast. Yeah.
Oh, that's great. Okay.
Yeah. Cool. So we saw how to send a transaction by crafting the transaction yourself. Let's see how to use ContractKit in like a more user-friendly way where you don't have to like do all of these things yourself. First, like real quick, this isn't actually sending a transaction, but it's just showing how to read account balances from a using ContractKit on an address. So ContractKit has these convenience functions for just like getting, it's called getting the gold token, but this is just the Cello token address. It's again like Cello used to be called Cello Gold. And it was easy to change, like update Cello Gold to Cello, and a lot of the more public-facing resources. But in the code, it's much more difficult to change the references to Cello Gold because things will actually break. Like a lot of the code will break if we don't update the references. So we still have a lot of references to Cello Gold at the code level. So you'll see these like gold token references. This just means Cello. But we can get the Cello token contract address and the CUSD token contract address with these basic functions, and we can just read the balances of this account address with a simple just like balance of call. And I'm going to print these two things using the following two lines. So just to run that real quick so we can see what they return. Looks like this address has 140 Cello and 248 Cello dollars. This is an address that we use for a lot of our examples and tutorials. So people are sending this account funds frequently. But this comes in handy like when we get to the next section of like actually sending transactions using ContractKit, because we'll send a transaction using like a transfer, and then we'll read the balances after the fact to see how they changed. So to actually send Cello in CUSD using ContractKit without having to create transaction objects, again, we get the gold token and stable token. But once we get those, we can just call like the gold token wrapper. We can call like gold token.transfer, specifying an address that we want to send to, an amount, and then we just call .send, saying who we want to send it from. And ContractKit will actually fill all of the other transaction parameters that we define manually above. ContractKit will just automatically fill that in. So you just basically need to say who you want to send it to and how much you want to send, and then it will do it. Just to note, in this second transfer where we're sending Cello dollars, when we're sending, we can specify who it's from. This has to be whoever's signing the transaction, so whichever private key you have access to. But you can also specify the fee currency in this field. So you can say, oh, I actually want to pay my Cello dollar transfer. I want the fee currency to be in Cello dollars. And you can just say fee currency is the stable token address, which makes it really easy. So once we send those, they'll be broadcast to the network. Then we're going to wait for the receipts. And once we get confirmation, we're going to log these links to the block explorer so we can open them up, and then we'll reread the balances and print the new balances. So let's run that and see how it goes. Cool. So we have two transaction links, and then we have new balances. Let's open up this Cello dollar transfer, and Deepak will see if we can figure out if people are receiving Cello dollars for transaction fees or if it's being converted into Cello. So we sent 0.1. So down here we can see here's the token transfer. So we transferred 1/10 of a Cello dollar, which was the actual transfer amount. And then we have these additional transfers, which are going to be related to paying transaction fees in Cello dollars. So 9A8, this first one, is the account that we're sending from. And it looks like it's going to this account, which is CLabs Validator 5. So that token transfer looks like it just sent Cello dollars directly to the CLabs validator on the Alpha Voice network. Let's see what this other one looks like.
Hey, Josh.
Yep.
Hey, I have a quick question, and I apologize. I sort of came late to this, so I hope I'm not making you repeat yourself. But I noticed that on the docs and on the slide, it says that any sort of ERC20 standards can be used to pay the gas fees. but how does that necessarily work? Just because, I mean, there's probably very illiquid ERC20 tokens out there.
Yep. Yeah, that's a good question. So there's functionality in place to basically enable any ERC20 token to pay transaction fees, but there's actually a whitelist of ERC20s that are allowed to pay transaction fees. So currently it's only Cello and Cello dollars that can pay transaction fees. But like Cello Euro presumably will be able to pay transaction fees in the future. So ERC20 contracts need to be added to this whitelist before they can actually be accepted as transaction fees. And the way that happens is through the on-chain governance process. So if you create your own ERC20 token and a lot of people use it and it's like a very useful token on the Celo network, you could create a governance proposal and like rally the community to include your ERC20 token on that whitelist.
Okay, awesome. Thanks.
Yep. Cool. So Deepak, it looks like validators are actually receiving transaction fees in Celo dollars, which is pretty cool.
Yeah, thanks. And I think maybe this is not that relevant, but just curious, like, so there were like 2 fee transactions. Is one of them going to the governance contract for the community fund from here, or the validators are paying for that afterwards?
Not totally sure. Like, so this first one is going to the validator. This second one is going to this contract, which on Alpha Horace, it doesn't look like it's labeled or the source code has been verified. So I don't actually know exactly what contract this is. It'd be interesting to like jump into the Cello mainnet. Let's see if we can find a CUSD transfer real quick. Or maybe that's not totally sure. But yeah, I'll have to look into that and get back to you.
Yeah, that's okay. It's not relevant, sorry.
Cool. So the last little section in this code bit in the lesson.js that I want to go over is using Ethers.js with Cello, because Ethers is such a common library in Ethereum now, and it seems to be like the library of choice for newer developers. So this is just the intro on how to get started with Ethers with Cello. We imported the libraries, and essentially Rossi, one of the community members, created a wrapper for Ethers.js for Cello. So I can just like create a Cello provider with the Ethers. Like before we did this with Web3, but now I'm just doing it with Ethers at the same endpoint that I had above. I wait for that connection to be made, and then I can create a new wallet using that connection and then the private key for my account. And then essentially creating a transaction is as easy as just saying like wallet.send transaction, where you specify the to address and then the value that you want to send. So very similar to ContractKit, where it's simple. It will autofill a lot of the transaction details for you. And then once that's created, I just wait for the receipt, and then I can print it again. So I just run this real quick. It's sending the transaction. We're waiting for it to be mined. There it is. And then, yeah, this pops up. And we have, our transfer's been made. So yeah, I hope that's helpful in just showing how to do some transactions like programmatically using the tools, and gives you guys some more context in terms of how things are working kind of under the hood. What I want to do next is I have an example of how to send transactions with the Cello extension wallet, which I think could be helpful. It's like very bare bones. I'll just run through that real quick, and then I'll show how to send a transaction using the mobile wallet. So what I'll do is I created this web page directory in the GitHub repo that I shared, and it has just like a basic web page with like very simple JavaScript for making a connection to the network and then doing these transfers. I'm just going to run through what it looks like from the user side, and then I can jump into some of the code if you guys want. But I included a bit of instructions in the README on the GitHub repo as well. So let me just run. This is a simple web page where there's literally just 2 buttons: connect extension and then send CUSD. I already connected my extension to the page, so there's no error handling. So when it's already connected, it's not going to fail appropriately. It's just not going to do anything. If I click the send CUSD button, the extension wallet will pop up, and this is a hard-coded amount of Cello dollars that I want to send. And this is I'm sending it from my account to this other one, specifying gas price and all these things. I can just confirm here. And once it goes, I can actually, you guys can see the extension, right? Sometimes it's hidden. Okay, cool. Yeah, and the send CUSD just worked. I can pop it open in the Explorer. Looks like it's been detected, but it's waiting confirmation. But it's pretty straightforward for sending Cello dollars using this extension. It's quite easy. This JavaScript for this web page is only like 50 lines, and that's yeah, essentially 15 lines of configuration. This is connecting the Cello wallet to your web page. You just get the provider, instead of being that Figment data hub that we were using in the Node.js file. Our provider is now an injected Cello object from the extension. And then once we have that, like the send function for clicking that button is essentially just this. I can say, oh, the CUSD contract, I want to do a transfer, specifying 2 and the amount, and then sending from the extension. So I know this is probably kind of a lot, especially since I didn't review the whole 50 lines of code, but we're getting up on time, and this code is in the repo with some more explanation in the README. So you guys can take some time and dig in a little bit, see how this works, because the Cello browser extension wallet is a fork of MetaMask, and MetaMask is by far the most popular wallet on Ethereum. So providing an interface like that will be familiar to a lot of people that have been working with Ethereum and just like playing with Ethereum. So being able to provide an experience that users are familiar with is really powerful, just because they don't need to rebuild mental models and learn how to use a tool. The interface of the Cello extension wallet is super similar to MetaMask as well. So it's nice for users.
Quick question on the wallet, Josh. So first of all, why is it not within MetaMask itself? Like, why is there a fork to begin with?
Yeah, so MetaMask doesn't actually connect to like different EVM chains right now. They actually just recently added support for like connecting to Ethereum layer 2s. And there's actually an additional complication, since the Cello transaction object is different than the Ethereum transaction object. You can't just use Ethereum signing tools for signing Cello transactions. You have to use Cello specific signing tools because we have those 3 additional fields in the transaction object. And
got it.
That being said, there's planned for like a upgrade that's happening soon in the donut hard fork of the Cello network. Cello will be supporting Ethereum transactions, so you can use MetaMask out of the box to sign Cello transactions. Like, they will be valid transactions on the Cello network. I'm still recommending that we use Cello signing tools where possible, because down the road, when gateway fee recipient and fee currency are like required, then you won't be able to use Ethereum signing tools. If you want to pay transaction fees in alternative fee currencies, you will not be able to use MetaMask, because MetaMask does not recognize the transaction object field of fee currency. So if you want that functionality, you need to use Cello specific signing tools.
Got it. Also, one more question on the experience with the extension. So it seems like if there's like a high throughput of transactions being added, right, to the blockchain, then the experience of opening the extension and again might be slightly jarring for the users. I'm just wondering if there's like another way to like move around this, or any other like design features that you would suggest to look into.
Yeah, so yeah, using an extension wallet for people that are not familiar with crypto is like something that they're not familiar with. So this is definitely something that's more useful for like maybe crypto power users or people that have been in the space for a little while. But in terms of accessibility, there's a barrier there. We're working on adding Wallet Connect support for Valora, so then you can actually have your Valora mobile wallet, which is handling your private keys, and then make connections to dApps that way. And then when you prompt users to sign transactions, there will just be a pop-up on Valora and say, hey, do you want to sign this transaction? I'm going to show what that can look like on this emulator here in a second. But we're trying to build a mobile first blockchain here on Cello, and like really think about user experience from the beginning, like not necessarily just building off of what has already been built, but like what do users expect, and what how can we make it more accessible for users. And the mobile first approach is definitely integral to that. But creating a browser extension was just really important for making it more accessible for developers that like want to have a rapid development experience. Like using this mobile flow that I'm about to show is really cumbersome for developers. So we've found that like the MetaMask type extension is really helpful for just like building proof of concepts and MVPs. And then when you get to more advanced stages, you can do different types of key management.
Hey guys, yeah, one of the things to consider, at least this is the way I built it, and you know, is if you want to be totally decentralized, or if you're okay with sort of a custodial type of point of view, what we do is we create the wallets on the fly when someone registers on our platform. Then we encrypt the keys and all the things that allow us to sort of interact with the blockchain. And if you are a power user of sorts that wants to export your NFTs or tokens to other wallets, we provide a sort of export process that allows you to verify your sort of identity through a multi-factor sort of authentication. And then you can put it in the MetaMask or whatever wallet you like at that point. The benefit to that is we can, you know, provide, in our case, generation of the tokens and points on the fly, you know, in correlation to the actions happening on our platform, which is a point-based system. And there's no need to sort of figure out where to get Ether or Cello or any of those other types of tokens. We handle all that for them. The drawback in that scenario, though, is the fact that, you know, diehard blockchain folks are going to say, well, it's not 100% decentralized. But the plus is we can do transactions in real time, and we can address basically 99% of the market who's never heard of MetaMask.
Got it. No, that's helpful. Is it okay if I connect with you after, Reuven?
Sure. Yeah, I'm happy to give you guys a demo on how we built it. You know, we've done a lot of this already, so I can share it.
Okay. Awesome. We're just ping you on Discord. Thanks.
Yep.
Yeah, I think that's a great point though about like how centralized or decentralized does your product or service need to be, and like totally depends on your audience. Like you said, like people that have been in crypto for a while might gripe about, oh, this is centralized service. It's not great, or it doesn't fully leverage the capability of blockchain. But I think it totally depends on who you're trying to serve. Like, what do they need? Everybody's building different products. There's definitely a place for like centralized service providers on an open public blockchain network. So yeah, I think that's a great point. So yeah, real quick before we wrap up, I would just want to show what this can look like on the mobile experience. So I modified the truffle dApp kit example, the truffle box, where we show how to use the dApp kit SDK and then connect with the Alpha Horse wallet. So in the dApp kit, we connect to like a Hello World contract and send contract updates to set the name there. I modified it so it just sends a small amount of Celo dollars. So yeah, just to go through the user flow real quick, I can click the login button and I have the Alpha Horse version of Valora here. So like it's Valora, but it's making connection with the Alpha Horse testnet. And I have it, I signed up for an account. So I'm going to connect my account to my demo app and I can see my account address, my phone number, and then I have a Celo dollar balance. It's actually like 9.9 Celo dollars, but like I said before, there's 18 decimal points on these currencies. So then I have a input amount where I can just say I want to send one Celo dollar. Well, it's one tiny fraction of a Celo dollar. But I'm going to send this amount, and then my app will prompt Valora, like prompt the user to sign the transaction with Valora. So we were doing this transaction signing before. Instead of doing it programmatically with the script, now I'm just having the user press like, okay, I want this Hello Cello app to sign, like I'm approving this transaction. So then the user needs to put in their PIN. And then it will pop back to the app. And then you can see over here, like a bunch of the transaction receipt is logged. I actually have a link to Alpha Horse again, so we can pop it open and see that in the token transfer, I sent a tiny fraction of one Celo dollar. And then these additional fees are the transaction fees that are being paid in Celo dollars as well. So I don't have the code to show exactly how to do this in the dApp kit example. I don't have this in this repo that I shared right now, but I'll upload this code to a repo and then I'll share it with you guys as well on Discord, the general channel. So then you can see how to use dApp kit to do this transaction signing and transfers with Valora. It looks like we got a few minutes left, so if you guys have any questions, if you want to see some of the code on that app side, this SDK for building this mobile app is using React Native, and the dApp kit is designed to work with React Native, and then the Expo development framework for mobile development. So, yeah. I hope this was helpful, guys. Feedback would be appreciated because this is the first time I've gone through this material. I just made this repo the other day and put all this stuff together for you. So yeah, if it's helpful, love to hear, and I don't know if I should share with others.
Yeah, it was really helpful. Thanks so much, Josh.
Yeah.
I had a question, like with the React Native, because the SDK is only React Native. So essentially, if you build like with a different stack, but still leveraging like, of course, the Cello backend, and then let's say you build like on Vue or Angular, I know it's open source, but what's the process of essentially now submitting it as a fork or like just creating a separate repo, and then how would you like open it up for users to use then on Cello as well?
Yeah. So the way that dApp kit is managing the connection between like my example app and Valora is through deep linking. So if you want to, right now, yeah, deep linking is just implemented in dApp kit through, with React Native framework in mind, but you can use any framework. Like deep links aren't specific to any framework. So you just have to write some tools to basically craft the deep links in your framework of choice. And like dApp kit, the SDK is only a few hundred lines of code. Like it's very lightweight. So it wouldn't be super hard to adapt other frameworks for it. And if you're interested in doing that, I'll definitely help you with additional support and see if I can get any C Labs engineers to help. Because I think this would be a great community tool to build and open source and share with everyone.
Yeah, no, appreciate it. Thanks.
Yeah.
I'll definitely reach out.
Awesome.